Okay, folks, sorry I'm not there yet today. Today we're going to work on the mean value theorem. Mean means just the average value theorem, and its special condition Rawls theorem. We'll focus on the mean value theorem for a minute. What I'm going to do in this video is I'm going to go over the homework so you can check that off your list. Then for today in class, you are going to complete problems 1, 3, 4, and 6, and then you're going to send me a picture of those problems, and then I'll record that as complete or not complete. I will, however, go over 1 or 2 of the problems. I'll maybe even set one of them up so you know how to proceed with the problems. And all we're going to be working on is the mean value theorem, which says that if a function is differentiable between 2 points A and B, if it's differentiable between 2 points A and B. Now, differentiable just means it's going to be smooth between A and B. And it's continuous at all points, including A and B. That means there's no holes. And that means there exists some point C whose slope at point C matches the average slope of the interval. So that means that there has to exist at least one point where the slope, f prime slope at C, is equal to the average slope, which is phi bar. Okay, so on the homework, we'll be working on this graphically. Okay, I'm going to go over the homework problems that you have. Quick shout out, Haley, say hi to the class.
Hi, class.
Okay, Haley's there. So once again, we're working on the mean value theorem, and I'm actually going to break these problems up and go kind of out of order. And the first thing I'm going to look for is I'm going to look for problems that meet the condition of the mean value theorem. The problems, first thing I'm going to mark off on each one is the average slope. So I'm going to do something wrong at first. Oh, what did I do wrong? That's right. That is not the point that it goes through because there is a hole there. The average slope would be this red line right there. And it's not a perfect line, but you're going to live with it. We're going to come to this next function. There's the average slope, approximately. I'm going to come to the third problem. There's the average slope, approximately. So what we're going to look at is which functions meet the conditions of the mean value theorem. And there's 2 conditions. It has to be differentiable on the inside and continuous all over in that interval. So I'm going to look, and first we're going to look and see if all the functions I'm looking at are smooth in the middle. And all 3 functions are smooth, so it meets the first condition of being differentiable between the 2 points. But what about continuous? Well, this function here is obviously, it's differentiable, but it's not continuous. How about the next function? Once again, differentiable, not continuous. And the third function is differentiable, yes, and continuous. So this one meets the conditions, or meets the hypothesis of the mean value theorem. Because this meets hypothesis, it means there has to be a point. There has to be a point where, oh, that's terrible. Let's try it again. Where the instantaneous slope matches the average slope. That point has to exist. Now, the other 2 did not meet the hypothesis of MVT, so that means there doesn't have to exist a point where the slope matches the average slope. Now, I'm going to be very careful when I say that. It means that there doesn't have to be. There might be, but there doesn't have to be. And sure enough, this one right here looks like it has one, but it doesn't matter. It didn't meet the condition, so the conclusion will then not necessarily be true. So when we're working with the MVT, we're looking to find ones where the condition is met. Once that condition is met, we know that point has to exist. And if you're wondering why we're going to use this, eventually we're going to prove the conditions meet and not necessarily use the not necessarily find the point where it works. We just know that point has to be there. So that was the homework from last night. We just did it graphically. Today in class on problems 1 through 1, 3, 4, and 6. We're going to work these problems algebraically. The first one says, state the mean value theorem. Okay, now, if you look back in this video, you'll have it to complete. But remember, there's, lots of blank pages here. There is, I'll get you started out. If there's 2 conditions that have to be true, one of them is over the interval AB without including the endpoints, and one is including the endpoints, then there exists at least one point such that, and this is the mathematical way of saying it, I'm going to start it for you, I'm not going to finish it, f prime of c equals some fraction. I'll let you fill that in. I guarantee you this question exactly like this is going to be on your next quiz because it's often asked about on the AP exam. So question 1 is state the mean value theorem. The key is you have two ifs, and then you have a then. Okay, so 3, 4, and 6 are standard problems. I'm going to flip the pages here. Right there. Okay, problem 3 says g of x equals 6x to the negative first, and we're trying to prove the mean value theorem between the points 1 and 4. Now, I'm going to tell you can use your calculators on this. Usually they are calculator problems. If I graph that equation, what it looks like is this. 1, 4. It's not exactly right. You'll live. Question is, does it meet the conditions of the mean value theorem? Is it continuous and smooth between 1 and 4? Yeah. The only point this is discontinuous at is 0. You usually don't have to check on functions because you'll know that they're going to work. So now I'm going to try to prove the conclusion of the mean value theorem. So if it looks smooth and continuous, then I know, and I'm looking over the interval 1 to 4, there has to be a point such that, this function doesn't have an f on it, it has a g, such that g prime of x equals gib gaba. G of 4 minus g of 1 over 4 minus 1. So I'm going to fill in the information I know. So I put all this in my calculator, and I got this answer to be equal to negative 3 over 2, which makes sense because the graph is going down, so it's going to have a negative slope. But now I need g prime of x. Can I find g prime of x? Yeah, I can. That's going to be negative 6x to the negative 2. So I'm going to write that function on down. Negative 6x to the negative 2 equals negative 3 over 2. I'm going to pause and bring this to another page. So you can solve this a couple different ways. If you have your calculator, you can use the solver feature right on the calculator. I'm going to do it algebraically first. I'm going to divide both sides by negative 6. I'm going to go to my calculator. Negative 3 over 2 divided by negative 6. Hit enter. I got x to the negative 2 equals 1/4. To get rid of that negative 2, I'm going to do to the negative 1/2 on both sides. So I'm going to go 1/4 to the negative 1 over 2. And I get that x is equal to 2. So that tells me that on that interval, at the point 2, the slope at 2 matches the slope, the average slope of the interval. So I know I kind of jumped all over the place on this page. It's really about keeping track of certain things. You're going to have your original function. You're going to use your original function to find your average slope. Then you're going to set that equal to your derivative of the function, and then you're going to solve. So every time that's all it's going to be, I will actually walk through problem 4. Now, yeah, 4. Now I'll walk through 6 with you. 4 I'll let you do on your own. You'll live. Okay, here we go. Now my goal is to get you out of here with as little work as possible before the period ends. What time does that period end? I think it's 1:07. I can't remember. H of x equals 5 minus x to the 1/2 between the variables interval 1 and 9. You notice I already changed the radical sign to 1/2 power. And the first thing I'm going to do is check it on the calculator to make sure it's smooth and continuous. Okay, so I've graphed it on my calculator, and I have confirmed that it is a smooth curve. So what I'm going to do now is the order you do this in doesn't matter. You're always going to be finding these things. I'll find h prime of x. H prime of x is going to be negative 1/2 x to the negative 1/2 power. Okay, so I'm going to compute the average slope first, which is going to be f of 9 minus f of 1 over 9 minus 1. And I'm going to put it into the calculator just like that. Pause this. So I put all that in my calc, and I got this to be equal to negative 0.25. That means that the instantaneous slope, negative 1/2 x to the negative 1/2, is going to be equal to negative 0.25. So I'm going to rewrite that over here. 1/2 x to the negative 1/2. It's going to be equal to negative 0.25. And negative 0.25 makes sense because the graph is decreasing. So what am I going to do? I'm going to do this kind of in one step and then put it all in the calculator. I got to get rid of negative 1/2, so I would multiply both sides by negative 2. So I've got x to the negative 1/2 equals negative, wrong answer, negative 2.5 times negative 2 is equal to 0.5. And to get rid of the exponent, remember the exponent on this side would be 1, so I'm going to put it to the negative second power. Negative 1/2 times negative 2 is 1, so x equals 0.5 to the negative 2. Enter, and I got x equals 4. That tells me, because it's met the conditions of the mean value theorem, that this function, h of x, between the interval 1 and 9, has an average slope of negative 0.25, and one of the exact points has to match, and that point is at x equals 4, has the same exact slope. Terrible picture. You're going to live with that, though. Okay, long video, but I went through 2 of the problems with you. I left you the easier one to do. I need you to send me a picture of 1, 3, 4, and 6 in Remind, and that will count as you're completing your work/homework for today. If you don't get it done in class, you can turn it in to me tomorrow, but you can get it done in class. Okay, folks, I'll see you tomorrow. Take care.